Okay, so welcome back, guys. We are here just to solve the tutorial sheet 4, Mungushi University. Okay, so question 1. We start with question 1 first. The question is saying, a stone is dropped from rest into a well. The sound of the splash is heard exactly at 2 seconds later. Find the depth of the well if the air temperature is 10 degrees. Okay, so here's just a matter of understanding the question. We are trying to find the depth, the distance. Okay, so if you throw a stone, we know, let's say maybe you have something like this. So you throw a stone, then they are saying, we know to say a sound is going to be heard. So for us to solve this question, we need just to go direct. First of all, we need to know the temperature. Okay, so we have been given that the temperature is 10 degrees Celsius. Then again, we know that since it was traveling in air, we know the velocity in air. That is just 331 meters per second. Okay, then from there again, what else do we know? That's what we know. Then from there we can calculate the speed of sound. So we know that we can calculate the speed of sound using this formula. Speed of sound is equal to, this is, by the way, this is meters per second, the square root of the temperature over 273 Kelvin. And the temperature here is supposed to be the absolute temperature. So we are going to say the absolute temperature is equal to 10 plus 273 Kelvin. So the temperature which we are supposed to use there is 283. 283 Kelvin. Then I substitute there. I'm going to get 283 Kelvin over 273 Kelvin. If you do the math there, you get the calculator. We are supposed to find 337 meters per second. So this is the velocity which this stone was going down with. But now the question is, we need to find the distance. So from here, if we want the simple way which we can use, we can just use this formula to say velocity is equal to distance over time. We are calculating the distance and we have the time. We have been given the time as 2.00 seconds. So I'm going to say velocity is equal to, we can just make d as a bit of formula. Then we are going to have d is equal to vt. And d is equal to, the velocity is 337 meters per second times the time 2.00 seconds. Our distancing, if you do the math there, we are supposed to find 674 meters. So that is question 1. Done with question 1. Okay, we go to question 2. Okay, question 2. Question 2 is saying, a person standing 1 meter from a portable speaker hears its sound at an intensity of, so an intensity of, we have been given the intensity as 7.5 times 10 to the power negative 3 watts per meter squared. Then what else do we know? The question is, find the corresponding decibels level or decibel level. So now we know, guys, the formula for decibel levels. It's just B is equal to 10 log of, open brackets, I over I0. Okay, so I over I0, where I is our intensity, I0 is the loudness, Okay. So now we need to understand one thing. The loud which someone can hear, the intensity of loudness which someone can hear is, we need just to know this is just constant. It is 1.0 times 10 to the power negative 12 watts per meter squared. So that is our I0. So in that case, we have everything we can plug in now. So we're going to have our D10 log of, we have 7.5 times 10 to the power 3 watts per m squared over 1.0 times 10 to the power 12 watts per m squared. So if you plug in there, you have your calculator and plug in there, we are supposed to find 98.75. 98.75 dB. So this is question A. Okay. Then B is saying find the sound intensity at a distance of 35 meters, assuming the sound propagates as a spherical wave. Okay. So as we know, so we're talking about B here now. We're on question 2B. As we know that intensity is equal to power over area. So we are talking about the first intensity. We have been given that the first intensity had what? 1 meter. Okay. Yeah, that's what we've been given. We've been given that is 1.00 meters. So we are trying to get the second intensity, which we don't know. So if this is true, but if we can leave the question saying find the sound intensity at a distance of 35 meters, assuming that the sound propagates as a wave. Okay. Then if this is true, we can say, if you can remember very well from what we used to do, we said these two guys, this is just, we can say it is, or let me take you back a bit. We can say intensity is direct proportion to frequency squared. At the same time, intensity is direct proportion to amplitude squared. So we know that these two guys, they are coming as a result of the power. Therefore, we can come up with the ratio to say intensity 2 over intensity 1 is equal to power over area. So we can say area 2 over, and again power over area 1. So from here, if I want, I can say intensity over area 1 is equal to this one. If you're talking about the spherical, we are talking about the area there is 4 pi r squared. So I'm going to replace this guy with what I have on area, both sides. But since this is area 2, I'm going to represent this r as r2. When I come to area 1, I'm going to present r as r1. Then I'm going to come here and say area is equal to, here I'll have this. So I'll say 2 over power over 4 pi r squared 1. So this expression here is the same as I write it in this form. It's the same thing. So I'll say divide. It's the same thing as this. So I can interchange them. Then I say this. This and this one will cancel. Pi 4 will cancel. And I'll have my intensity 2 over intensity 1 as equal to I'll get this. So I have R1 squared over R2 squared. So I have my R's. I have my R1 as this is my R1, but I don't have R2. Oh, R2 have been given now to say, so I have my R1 as 1.00 meters. I have my R2 as I've been given what? 35. Yeah, 35 meters. My goal is to calculate the intensity 2. Then I'll come here. Then I'll say, since I want to find this guy intensity 2, it's the same as I say I'm going to cross multiply there, and I'm going to have my intensity 2 is equal to R1 over R2 I square both sides times intensity 1. I plug in the values. My R1 is 1.00 squared over 35.0 squared times my intensity, the one which we have calculated the intensity. The intensity which we have been given, it is 7.5 times 10 to the power -3. So if you do your math there, you should be able to get our intensity 2 as 6.12 times 10 to the power -6 watts per meter. That is the answer for B. Then the answer for C is find the decibel level at a distance of 35 meters. So the same formula which we did first equation. So now we're talking about question 2, but C. Okay. So the same equation which we said 10 log of I over I0, where I is the the intensity and I0 is the loudness. So the loudness which someone can hear is 1.0 times 10 to the power 12 watts per meter squared. So we have found this as our I. We have found that it is 6.2. We have found that it is 6.12 times 10 to the power -6 watts per meter squared. So we're going to press this one there, this one here, then done. Then I'm going to replace there to say 6.12 times 10 to the power 6 over 1.0 times 10 to the power -12. What are we getting? So we are able to get 7.88 dB. Question 2 done. Question 3. So question 3 is saying two trains on a separate track move toward each other. Train 1 has a speed of 1.30 times 10 to the power 2 kilometers per hour. Train 2 has a speed of 90.0 kilometers per hour. Train 2 blows its horn, emitting a frequency of 5.00 times 10 to the power 2 hertz. What is the frequency heard by the engineer on train 1? Okay, so from the question we can see that we have got observer and the source. Okay, so let's say we have this car here. So we're going to call this one as our observer. And we have another one. So this is our source. Okay. So from the question here we can say the first one we can say from the question here you can be able to understand to say train 1 has a speed of 1.3 times 10 to the power 2. This one we can call it as what? As the observer. Okay. So meaning our V for observer is 1.30 kilometers per hour. And then our V for source is 90. Is it 90? 90 kilometers per hour. But we know that we are supposed to change these velocities to what? To meters per second. So for me to change this one, I'm going to say 1.3. Sorry, this one was times 10 to the power 2, which is just basically same as 1,300 or 130 in short kilometers per hour. So for me to change this one, I can say 130 km over h times how many meters are in one, or how many meters are in 1 kilometer. So we'll say there are 100 or 1,000 meters in 1 kilometer. Again, how many hours or how many seconds are in 1 hour? So in 1 hour we are going to find 3,600 seconds. Therefore this guy and that guy can cancel, this guy and that guy can cancel. So do the math there. If you do the math there, we will be able to get our velocity for observer to be 36.1 meters per second. Same with this guy here. I can say 90 kilometers per hour times 1,000 meters per 1 kilometers times 1 hour, 3,600. This and that one cancels. If I do the math there, I'm going to get my Vs as the velocity for observer to be 2.5 meters per second. Okay. Then from there now I can lab that part. Okay. I can lab this part so that I have the space. I can lab this part to have space. Therefore, I have my velocity now, my new velocity I'm going to replace there as my V observer as 36.1 meters per second. I also have that velocity as 2.5 meters per second. Okay, so I can move this to create space. Then now we go to the question. What are we supposed to do? Okay, so here what we're supposed to do is the first thing what we need to understand is the signs. Okay, so here we're talking about the fundamental what? The fundamental frequency. Okay, so we know that the fundamental, or maybe yes, the same one, we have the Fs. The frequency of observer is equal to the frequency of the source times the velocity of then we have plus or minus Vs, or we can start with Vo over V minus plus Vs. So I want to explain something here. What we need to understand, guys, is this. When the observer and the source, they are moving toward each other, like in this case, then we are supposed to use the signs. This is the general formula. We are supposed to use the signs we get here on top as positive, down here we get negative. But if these two guys, observer and the source, they are going away from each other, then we can use on top as negative, then down there as what? Positive. So here, from the question, they are saying these guys were going toward each other, meaning we are going to use, on top we are going to use positive, then down we are going to use negative. So it's just the opposite of each other. Okay, then now I can come up with this formula to say the frequency of observer is equal to the frequency of the source, the V, the velocity, the one we know. This is the velocity we know, 343. The velocity we know, 343 meters per second. So plus, since they are going toward each other, I'm going to use plus here. Always. Then here I'm going to use minus. Then I start now plugging in the values. I have the frequency of the observer, or the source. So I'll say I have the frequency of the source as what? What I've been given the frequency here is 5. Is 5 point what? 5.00, which is just the same as 500. Then I have 343 plus the velocity for observer is 36.1. 343 minus the velocity for the source is 2. We have found what? Was it? If you do the math here, we are supposed to get 25, not 2.5. Supposed to get 25 meters per second. So here is supposed to be 25. Then if I do the math there, you get your calculator and plug in the values. We should be able to get 596. So that is the answer for question 3. Yeah, question 3. Question 4. Question 4 is saying a turning fork vibrating at 512 Hz falls from rest and accelerating at 9.8 meters per second square. How far below the point of release is the turning fork when wave of frequency 485 Hz reaches the releasing point? Okay, so as we can see, we can, from this question, we have the frequency of the observer, the frequency of the source, the velocity of come on, we don't have the velocity. So since they are saying a turning fork vibrating at 512 Hz falls from rest, so it falls from rest, meaning we can conclude to say the velocity of the observer is 0 since it started from the rest. Okay, then and it accelerates, so we have the acceleration. How far below the point of releasing is the turning fork when the wave of the frequency 587 Hz reaches the reaching point? So we are supposed to find the velocity of what? The source. When we find that, then we are going to use the same velocity to do what? To calculate the what? The distance. Okay, so how do we do it? Here we come. The same formula. The frequency of the observer is equal to the frequency of the source, V plus or minus VO over V minus plus Vs. So let's understand the question. If we can understand the question, we can conclude to say the observer and the source are moving in opposite direction. If we can see, because they were moving in opposite direction. So I said, if the observer, this is the observer, and this is your source. If these two guys are moving toward each other, we are supposed to use on top here, I'm supposed to get positive. Down here, I'm supposed to get negative. But if these guys are moving away from each other, then it is another story. On top here, I'm supposed to use, in top here, I'm supposed to use what? I'm supposed to use negative. Here, I'm supposed to use positive. So, since they are moving in opposite direction, I'm going to use it on top negative, down positive. As long as you get those 2 points, then you're home and dry here. Okay. So, there we go now. We can plug in the values. We have been given the frequency of the observer. The frequency of the observer is 485. So we have 485 is equal to, again we have been given the frequency of what? The source, which is 512. Then I have this guy 343. I'm going to get what here? Minus 0. Here I'm going to get 343 plus the Vs is the one I'm trying to find, the velocity of the observer. Therefore, the quickest, okay, let's just do everything so that So here I'm going to have 485 is equal to, here if I do the math there, if I do the multiplication there, I'm supposed to get what? What are you getting? Okay. So if I do 512 times the 343, I'm supposed to get 1756.16. 1756. You can also confirm with your calculators. Over that one, I'm going to get the same 343 plus Vs. So I can cross multiply at this particular moment. Then I'll be able to get, if I do this time this one, what are we getting? We are supposed to get, let me punch, let me use my calculator. We are supposed to get 166,355 plus 485 Vs is equal to 17,561. So I can shift this guy to the other side. Okay, I'm going to have 485 Vs is equal to 17,516 minus 16,6 and 485 Vs. If I do the math there, I should be able to get 9261. I'll divide both sides by 485. My Vs I'm getting as 19.1. Okay, so that is my Vs. Okay, the velocity of the source. So now, if that is the velocity of the source, so I can come here to say if my Vs is 19.1 meters per second, and I have the acceleration to say what is my acceleration? 9.8. So it is g, 9.8 meters per second squared. Okay. Then from here, which formula can I use? I'll go back to equation of the motion. So if I have since we are talking about it, if I have these details here, how can I find the height? Therefore, I can use this formula. Let me rub this part. I can use this formula to say V final squared, V initial squared plus 2A S. I'm trying to calculate, so my S in this case is the height. So I can replace H with H, S with H. So I come. So now, if we can understand this question, the moment when it reaches down, the final velocity is going to be 0. Meaning, my V initial is going to be the velocity of the source there. So I'm going to have 19.1 squared plus 2 acceleration, 9.8. But again, we need to understand something. Since this is g, we are going to take g as what? Negative. Okay, we are going to take g as negative. Or if you want, you can say my initial velocity was 0, meaning this is your final velocity. If you want, okay, maybe that way it can help us. So if I take it in that way, then I'm going to find that my final velocity is going to be 19.0 squared is equal to, since it was going down, my g is going to be positive. I'm going to have 0 squared plus 2, then 9.8 h. Okay, I get that one. What am I getting when I square that guy? I'm getting 364.81. 364.81 is equal to 19.8. No, 19.6. Supposed to be 19.6h over 19.6h, 19.6h. Therefore, my h is, what is my h? 18.6 meters. So this is my answer for question 4. Okay.